We're getting the spindle warmed up on the Flex CNC. I spent some time getting these curtains cleaned too. They had been kind of like fogged over. So we got those nice and clean so we can see a little bit better. So we got two workstations right here. This station is going to be for operation 1 and this will be for op 2. Whenever I go to flip this over here, we'll move this pig mat out of the way, and I've got some parallels to set in there, and we're using the smooth jaws. So for op 1, this will be our G54. We are using the Talon grip jaws to hold this plate. Got 2 vices stacked in there so that it supports the entire workpiece. And like I said, we'll take it out, flip it over here to this side. We've got our stops that we can rotate around here so that we can locate our workpiece in the correct position, flip it out of the way, and then finish milling the hat on this side, decking off the top, and chamfering it, and that'll be all for operation 2. And what I'm making is a couple of fixture plates, but this is also serving as another practice session for me and a demo that I'm going to be running for. There's some folks that's coming in that are local that want to see the Flex CNC operate because they're interested in buying one. So we're going to use this as a sample program whenever they come in. So I got a couple extras that we can do to or use to mill for a demo. But what they're going to be used for are adapter plates that will bolt to 2 of the rails, and then I have some large V-blocks that's going to be bolted to that. This is not the same V-blocks that I've shown in the past. It's a couple of other narrow V-blocks that have a nice big V in it, and that plate will bolt to here, and then the V-block is going to be pretty much permanently bolted to that adapter plate. There's no reason to really take it off at that point. So that's what we're going to be doing. Just waiting on our warm-up to get completed. We just change the RPMs and then let it run for a few minutes each time and let it warm up. I almost forgot to mention that this workpiece here is going to be our first work that we're going to be machining using Fusion 360 and posting it out for the Flex CNC. So Kevin over at mechanicaladvantage.com, he has a direct link to Autodesk. He works with them on the post processors for different machines, and they've been developing one for the Flex. And so we use that post processor to post out this program off of Fusion, and it's going to be our test piece. So they're kind of using me as somebody at the machine to test this out and see if it, how it works. If we have any issues or problems, I'm going to be letting Kevin know that, and then he'll relate that to Autodesk if there's any issues that need to be corrected. So hopefully we're going to have some success right out of the gate right here. Okay, I have the first part machined on op 1. There's a look at it. I have been making some significant changes and adjustments to the program. In fact, I'm going to go ahead and finish that before I show you some of the other stuff. So this is, I went ahead and made some more adjustments to our op 1 program. I'm going to go ahead and copy this into our file here. We're going to paste it and we want to overwrite it. Okay, overwrote the op 1 right there. That's got some feeds and speeds adjustments, also a depth of the tap. So a couple of things. The bolt won't screw all the way down through there. So I went ahead and adjusted the depth of the tap to go an extra 1/4 inch. I think that's going to cover it. All right, these 3 holes in the center are actually reamed. That's our last tool we used. So that's a .499 reamer. And these are the pins that I'm going to use right there. There's actually just going to be 2. The center hole is just to be used for locating over here in G55. All right, so I was checking the pin. It won't go in there. Here's some of our plug gauges right here, pin gauges. So here is a .499 plus pin gauge. All right, and it's trying to go down in there. It's a little bit tight, but it is going down in there in the hole. All right, and that's the same for all of them. It's going down in there. So I think what I want to do, I do have a 1/2 inch reamer. I think I'm going to swap out the 499 for a .5 reamer. We're going to do that. I'm not going to worry about retapping these. I'm just going to do these by hand. This is our first sample. I'm going to machine a couple of these as a sample, and then I'll have a couple more plates once I have all this optimized that we can rerun it. So I wanted to mention too that we started off We started off with it at 27 minutes. That's not accurate up here because I had to stop it and start over on a couple of occasions. First part was the program said it was going to take about 27 minutes to complete, and I now have that knocked down to 13.5 minutes total for everything, just for op 1, not op 2. I'm going to come back in there with the new reamer and ream those holes. And I'm going to go ahead and just test my feed rates because I had the feed rates wrong for the face mill. And it was taking a long time to get that face mill done. So I think I have everything about where it needs to be. I'm going to run another part off of camera and make sure I have this thing optimized and everything's good to go. And then if that's the case, we'll set up a third plate and we'll get a little video so you guys can see what the machining looks like on this, all right? But so far, everything's working pretty well. Machine's handling it pretty nice too, and it's making some good looking chips. I just got to get the feed rates dialed in, which I think I have them set right now. I swapped the reamer out, went ahead and reamed those 3 holes. So the 499 pin gauge is definitely going there easier now. You can push it in there a little more easy and pull it out. It's actually a really nice fit there. All right, the 0.5 pin gauge, which is on the plus side, is still a little tight going in. So I think that's going to be a good fit for our dowel pin now. It should press in there lightly and stay in place. So I think that's going to be pretty good. I did, like I said, I made adjustments to all of our facing operations there with our face mill. So I'm going to run over this right here just so that I can see how the cutter is reacting and see if it's moving like it should this time. I'm constantly learning and trying to improve how to use Fusion. There's a lot of fields in there that you have to look at. Retract feed rates, things like that you have to make adjustments to in order to optimize the time that you spend on a workpiece here. I suppose you can't have any success without a failure every once in a while, right? You learn from your mistakes. That seems to be the common theme for me with our CNC machines here. I had a pretty significant crash, as you can see right here, and I pretty well trashed this face mill. So this was a new 2.5 inch diameter Walter face mill that I just absolutely buried through the material right here. I think I can save it. I'm going to do like a manual deburr on it. You can see that it's like a prickly pear because it just ate through this mild steel right there and just tore the inserts up, tore the screws up, and roll those edges over. But I think we can save this and probably just put it in our toolbox and just use it on the manual mill. But I'm going to go ahead and get another one of these face mills coming. I'm going to go ahead and get a couple of them. This takes the triangular inserts, and then I've got their square inserts, which is what I'm using now. So I took this off and I found a 2-inch face mill that takes the square inserts and reran this, and you can see we're actually leaving, it's leaving a really nice finish on there. I'm real happy with that. It's got a really nice feel and everything is checking out pretty good on this workpiece right there. But we've got a really, really bad serration in that key. Now this doesn't matter. This is still actually a usable part because the way that this works is that this gets flipped upside down and these 2 keys line up with the bed rail. I believe that's 200 millimeter, I believe, and a 20 millimeter slot. So I've measured it. I think we've got about a half a thou or so clearance with the keys to fit in the bed. But this was just a big time bummer. And I'll tell you what happened. So on these Flex machines, the engineers have these guys set up to be safe around the operator. So you can see on the front, these yellow bars, that's your laser screen right there. So if you happen to reach your hand up in here like that during a cut, it's going to shut the machine down. All right, if you break that curtain. There's also one on the back here as well. Same thing. If you reach in here, it's going to break that. It's going to break that curtain and it's going to shut the machine down. The funny thing about this guy is that you can't really get close enough to this. You probably can. I haven't tested it in all the ways that you could probably test it, but where I'm standing right here is where I tripped that guy. Okay, so let me see if I can get you around there. You see how that light is orange and you get out of the way. So green is good. That's when you're running, okay? So I'm just going to step over here All right, now it turned red. You see where it's red? And you see I'm right here at the back of the machine. I'm gonna step back just a little bit more. It's orange. So what it's supposed to do is when you come into sight of that laser there within a certain distance here, it turns orange and it's gonna give you a certain amount of seconds in order to step out of the way and go back to green. And if you don't, it's gonna go to red and it's gonna alarm, it's gonna shut the machine off right in the middle of your cut, which is what happened. I was watching it cut. I came around here. I was about like this is what I remember. So you can see, I thought I was right here, but I was trying to get just a quick little video. Some of these videos I take because I share them with Kevin, because he's helping me with the programming. I share them with Aaron up at Flex because he helps me with the machine. So sometimes it's just quick little videos because I'm sharing the people that are helping me to see what's going on the machine. So I took a little video right here and I was stepping over here like this. Boom. See, it turned red. That laser turned red just right here. And it shut the machine off in the middle of the cut. So it was somewhere right about here that it turned itself off. So anyway, I thought I would share that with you. Not a fun crash that I made. But the good thing is that I've continued to tweak my program with the help of Kevin over at Mechanical Advantage. He's been helping me with all this, and we've got it optimized. I think there's still a little room for improvement on some of these ops, and I'm getting in there and I'm trying to tweak them to try to speed things up a little bit. It's movements of the face mill that's going into the cut and out of the cut that I'm still trying to get optimized and get it in here and get it done quicker. So I think this part's done, op 1. I need to move over to op 2 here. We got to find the center of that hole, and all we got to do is just mill the frame and mill the top, and it'll chamfer all the holes, and then that part will be done. So I'm going to keep working with it and making sure that this is right. I'll probably have to do some tweaking on this one. I'm not sure yet. But once we get to where we're at a good point and I feel good about it, I'll go ahead and show you a little bit of the machining for each one of these operations, and then we'll test fit it over here on the bed rails. I shocked myself on this second op. It looks as though we have a beautiful part that's on size, and I didn't have any crashes this time. I was really nervous setting this part up right here because I wanted to make sure that I got it centered properly and I had my Z set right. I had issues on the first time. Setting your tool over here on the Flex is a little different than what I'm used to on the Miltronics used on Renishaw. It's a little more hands-on over here, and there's a little bit of math involved. And once you do it several times and you do it on the regular basis, I'm sure you get used to it, and it's easy. So I have to re-educate myself every time I come back over here and make sure I'm doing something right. So I was able to get our tool height set properly, and it looks good. So I did grab my 1-inch mic and I mic'd all 4 corners, and we're getting 0.002 deviation on what I would call parallelism, you know, is it being same size all the way around. So it's not 100% perfect, but it's perfect for what we're doing here. A milled, you know, mild steel milled plate that's going to get bolted down here. And in the long run, once the V blocks are actually bolted on this thing and they're set up in here, you have 2 of them, you have a shaft that's sitting down in there. At that point, you can indicate the shaft. If you have any high or low in your shaft, you just basically shim it on either V block to get it nice and parallel to the bed down there. So that's how I'm looking at that. But real happy with this right here. It actually turned out pretty good. And this is the one that I crashed on the bottom side. I wanted to start with this. In case I came down here and crashed it, we would only have one, hopefully, that was crashed, but I think we got a good part. So that's the first one that I started with right there. You can see the finish is a little bit different on that one. So I'm going to go ahead and put that one in and make another test run at this and get that. But like I said, I got a couple more of these that I plan on cutting, especially for our demo coming. You can see right over there, I got a couple more of those plates because I want to have this set up for the demo that we'll be doing next week over here on the Flex. All right, here's a shot at one of the V blocks. You've probably been wondering about that, so I thought we'd go ahead and grab it and put it on there. And it looks like our bolt holes are matching up just fine. Just using these to see if the holes lined up. And this is why I decided to do dowel pins. So both of these V blocks will get set up in a machine, and we'll have to drill and ream the bottom of those for the 2 dowel pins so that we can dowel it together. And that's all just for alignment and making sure everything is straight. Once we take this and we set it down here on the bed rails like that, everything is going to be nice and straight and in line with the world and hopefully work out. All right, I'm happy with that. Finally making some progress on this. So I think what I'm going to do is go ahead and set up another one, and we'll try to get you a little bit of the chip making action, share that with you, and see how these things are going to machine. So I've already got the jaws cleaned off here. I don't know if I'd mentioned it earlier, probably did. These are those Mighty Bite Talon grip jaws. Pretty nice because you can move these guys around however you need. So we're going to take our edge work stop right here. I'm going to go ahead and swing it up. Tighten that up right there, and then we will push it to the left gently into the stop. Snug up our jaws with the short handle here. And then now we're going to loosen up our stop, let it swing down out of the way. And I'm going to grab the long handle and go ahead and torque both of those vices. I just do this by feel. I know that it's going to hold well. Just go back and forth and just kind of, you get a good sense there of what you're doing. So that feels good. We're ready to make some chips. Okay, I think we're ready to roll. We got you a new camera mount on the Flex there, mounted on the spindle, similar like I did in the Miltronics. I'm going to start this off slow just to be sure that we're going to the correct work location, because I've been working on the other setup and then a third setup down there. So I'm coming back to this one now. We've got our program ready to go. I'm just going to play with the feed rate here as we start. So here we go. I'm going to mention too, on this very first stop, we're using a 3/4 inch end mill. It does get a little bit rough on this cut, so I've been bringing the feed rate down to about 70 to 80%. So right now we're at 70% on my feed, slowly ramping up some. So it'll come all the way around the frame, the outside, and then we're going to make a 10-thou cleanup pass to clean that finish up. to go up to 100%. There we go. A little bit lighter on that side. All right, now we'll just do our cleanup pass. We've been having this issue with some electronic harmonics there, you hear, and we got Flex looking into that. It'll go away. Okay, so 2-inch face mill, we're using a Walter face mill here, taking 100 thousandths. This is a 2D adaptive program. Those feed movements where we're coming in and out of the cut is what I've been continuing to try to adjust and modify to speed the program up. And we've got it at a good place, I think. Places in this where it seems a little jumpy. I'm not sure how to improve that. I've been working with Kevin, Mechanical Advantage. He's been helping me with this program. I just think that we've got it in a pretty good place, especially compared to where we started. Okay, so this is our cleanup pass. Yeah, those in and out movements there, that's what I need to continue to work on. For the finish pass here, it's a little bit slower than when we were roughing it. There's got to be some feed rates that I've forgotten to go in there and change on this particular op. Taking too long to retract and come back down into the cut. right, so this is a 1/4 inch 4-flute end mill. It's a Walter end mill. And all we're using it for is to clean up the 2 keys. I'm gonna pause right here just for a sec. Since I've got to hit cycle start, I'm gonna go back in the manual so I can open the door. And I'm gonna see about cleaning that camera lens off for you. This is a 3/8 mill drill, just using it to spot a few holes. Got 3 holes in the center that are drilled and reamed. 2 on the outside are tapped half 13. So we're just putting those spots in. So next up is going to be a 31/64 drill bit. Now I don't have that in carbide here in the shop, so I'm using my a good old high-speed steel jobber drill to do this. And it's just going to drill 3 holes. We do have like a sort of a peck cycle just to break the chips. This is our Walter 27/64 carbide drill, tap size for half 13. It cuts through that 1-inch steel like butter. It's such a beautiful drill to see operate. All right, there's our 2 tapped holes. Let's see if we can finish this guy. Dang it. Dang it, dang it, dang it. That was technically my fault. I was trying to latch the door, and instead of latching it, I unlatched it. And the problem is now is I don't know. It looks like the drill tip is okay. I wasn't sure what was going to happen there. Beautiful chips though. I'm just gonna have to run that again because I don't believe it. No, it didn't go all the way through that last hole there, so I'm gonna have to start this over. As I said, I was having some issues with the machine here, and one of the engineers at Flex jumped in here on the controller. He found one thing that he needed to correct. There was something that needed to be changed in the software itself. They made that change. They said everything should be fine. So we're going to continue running, and hopefully that's going to fix the problem now. So next up here, we got our 2-flute chamfer mill loaded up, and we'll go through and chamfer all the holes and the perimeter edges, including the 2 keys. Our tool change is looking good. All right, we got a good working program there. This is a high-speed steel reamer, 0.500, ½ inch. I'm running this at 360 RPM, and feed rate's set at 10 inches a minute. Seems to be doing good. On my my first piece, we used the 499 reamer, and it was reamed on 499. So even with the ½ inch reamer here, the 0.5, the dowel pins have an interference, so they will press in there. So a good fit for the dowel pin. This should finish up the program. All right, there it is, all done. All right, so here's a look at our finished part that we just ran. Now I did see a couple of differences in here, and I was like, wait, something else is wrong, but then I realized what's happening here. So you can see our chamfers on these drilled holes here, and then compare them to that, not as deep. The reason why I remembered this, got that one little edge there, I need to knock that off where the deburr tool couldn't, the chamfer mill couldn't get in. Anyway, I got 2 of these plates from the welding shop. They burned out a few for me, and 2 of these were somehow slightly bent, and I didn't realize that until I set it in here and I started checking it. So they went ahead and burned me 2 more, and those are much more flat, but I'm still making use of these 2 that they burned out as our setup test pieces right there. So that's why it's deeper here than theirs, because the plate was slightly bent, and it was pretty badly bent too. I put a straight edge across there and then measured it, and it was almost a 1/16 of an inch bent, just almost like a waviness to it. So I don't know what happened there. So we'll go ahead and move this guy. You can see that we should have a good program. After this one, I tried to tweak some of the movements to try to get the cutter in there a little bit faster. So we'll see if it does it on this one. We'll move this guy out, put this one over here, and continue on. We'll just go ahead and set this somewhere right in here. We may have to adjust that. Make sure we got all of our chips off this side. Yep, slide it down against our work stop there. That should be good. Let's move our work stop out of the way. All right, guys, we're ready to start operation 2. This is going to be our G53 work location. I've already got tool 1 loaded up, so we'll come in, cut the outside perimeter, face it off, and chamfer the holes. I'm gonna take it slow just at the very start here and make sure that everything's good. It always makes me nervous when we first start here. Okay, it looks right. Let's go up to 100% on our feed rate. All right, we're gonna come over here and grab tool number 2, our face mill. Now, I'm not sure if this is gonna clean up the plate because of this plate being warped the way it is. Just keep that in mind. We'll find out here in just a minute. Definitely hear it. I think it's time to index those carbide inserts around. I've been seeing a little bit of sparking, indicating we may have some dull cutting edges. Yeah, you can definitely see the bend in it now. This side's supposed to be a 25 thou cleanup. I've got the first stop set at 100 thousandths deep and the second side at 25 to keep the total plate thickness at 7/8 once it's finished. Okay, that's done there. And I'm gonna just take a peek at this real quick. I gotta jump over to manual so I don't alarm on the door here. You know, just looking at that piece, I could, honestly, it really doesn't matter. I can use it because the V-block is gonna straddle all the way across and the bolt holes are on the outside, not in the bend there where the bend is. So it would still be pulling down flat on the ends of the V-block. What I was getting at was we could change the coordinate of Z and come in there and face it out again. I'm gonna go ahead, let's just go ahead and finish it though. Close that door up and we'll jump back into auto and hit cycle start. And I can always come in here and change our Z position slightly and just reface it and rechamfer it. Go into tool number 9. This is that 1/4 inch 2-flute chamfering mill. There's a better look at our Op2 finished up. The obvious sign of the bend in the plate that I was telling you about. Like I said, the welding shop went ahead and gave me 2 more of these, and I checked them, and they're much more flat than these 2 guys. But since they were bent, I wanted to go ahead and run them as test samples over here on this operation. And I think I got a little breakdown of my carbide inserts, so I'm probably going to index those guys, and on the next one we should have a little bit better finish there. But let's go ahead and pull this guy out, and let's see how they fit over here on the bed rails. Make sure there's all the chips are wiped off here. All right, let's see if it fits. Seems like it's a little tight. Let me see if it'll just bump in there. Oh yeah, you can bump it in there. That's good. So it's got a nice tight registered fit on the keys then. And then boy, we got it. We've got 4. We'll have 4 5/8 studs coming through with the flange nuts, and of course our V block's going to sit right through there. We'll have our 2 dowel pins that are going to be pressed in, and then the V block sits down. Once it's together, it's most likely just going to be a I'm not going to take the V blocks off the plate. There's really no reason to. We'll just keep them bolted together all the time. Let's give this one a try. The finish on this one definitely looks better. Let's see how good this one comes up to with the hit with the. So nice registered fit there. I think that was 200 millimeter. Same thing. That one went a little, there we go. This one was a little bit more loose, but I still tapped it right there at the end. So it's got a good fit there as well. All right. Happy with it. It's looking pretty good. Let's go ahead and bolt this one down to show you what this is going to look like. Remember that we don't have the V blocks drilled and reamed yet for our dowels, but this will show our setup completely. Already got some T-nuts down in the bed rails there, using some 5/8 hardware. Going with a 5/8 flange nut. We don't need to torque them down. And then we'll do some, we'll probably just use our 1/2 inch hardware here. Made the thumb too long. It's looking good. All right, well, there we have it. There's our example. It is nearly ready to go, and that's looking good. What I'd probably like to do with these guys, possibly once we get everything finished and ready to go, we may give these guys a nice coating of paint just to protect the rest of the bare metal surfaces, and just keep our machine surfaces here clean. I like it. I think it's going to work really well. So have 2 of these over here on the flex, and this will allow us to hold some nice large diameter, nice rounds over here. I'd like to get a couple of shafts in here and do some keyway cutting on it and get it tested out. I do need to make a couple of the clamp bars. I'm probably going to use a nice heavy piece of flat bar, maybe some nice thick rectangular flat bar, and something that we can just pull down on our workpiece there. And I believe I had touched on this before. If we get these bolted down, I'll do some indicating and see where these 2 surfaces line up with the 2 pair, or the pair of V blocks, I mean. And if we have to, all we got to do is just shim 1 V block underneath the workpiece to get it nice and flat and parallel to the bed rails there. But this project is really coming along nicely. I've got a couple more of these plates that I'm going to be saving, and I'm going to run these as a demo whenever that group of people come in. We're going to run a demo on another one of these, and I'll use my other piece of material. So this one's really just a, I don't know, we're just going to keep it and use it for other things. We're not going to use it for the V-block right there because of what you see there. I'd like two of them to be matched about as perfect as we can on height. So there we go. There's one little project done, and I was happy to show you guys that. And I'll bring you guys back for some more projects whenever we get started on them, okay?